Okay, so we'll go over some more information about these basic functions. We'll start with the line, and everybody should, of course, be familiar with the line. The difference is, main difference I want to emphasize between these examples line is their slope. This first one has a slope that is positive. Okay, we read a line from left to right. So as we look at this thing from left to right, the line is doing what? Increasing, it's rising. So it has a positive slope. Versus the next one has a slope that is negative, less than 0. Okay, the fourth one has a slope that's what? Well, the line is constant, and so since there's no change, we'd say the slope is 0. Very good. Okay, and we'd say this is equal to b. F of x equals b. It's a constant function. And then finally we have one. Looks like the slope is 1. Our intercept, or the y coefficient of the intercept is 0 because it goes right through the origin. And so we would say that this is f of x equals x. Okay, f of x equals x. If it has a slope of 1, it's going straight through the origin. We say this is f of x equals x. Okay. All right, we want to write a linear function f that has the indicated values, and then we're going to sketch the graph of f. So we've got f of 1 equals 0, and also f of 2 equals 1. Okay, so basically by saying that, they've given us what? 2 points. Okay, so we get the point 1, 0, and also the point 2, 1. Okay, those are our 2 points. And if we have 2 points, we can find the equation of a line that goes through them by using y minus y1 equals m times x minus x1. Okay, but of course first we need to find the what? The slope. Okay, so recall that the formula for slope is y2 minus y1 over x2 minus x1. So using the 2 points that we have, we can say 1 minus 0 over 2 minus 1, or what? Looks like just 1/2. And so we'll use y minus, doesn't matter which point we use. So y minus 0 equals 1/2 times x minus 1. Where? Oh, yes, okay, that's fine. 1 minus 0, 2 minus 1 is 1. Okay. So our slope is just 1. All right, so then in this case we get y minus 0 equals 1 times x minus 1, or y equals x minus 1. Okay, questions about that? All right, very good. Okay, you want to be able to find the equation of a line given 2 points. All right, so why don't you take a second and try it in example B. Any questions? Where'd the minus 3 come from? I multiplied 3/2 by 2, so the 2's canceled, and I got 3. Okay, other questions? All right, very good. All right, let's talk a little bit about piecewise functions. Piecewise functions, of course, are functions that are determined in or defined in pieces based on a value or a range of values. So for instance, well, first it says we're going to determine which line of the function applies to the number a when we're trying to evaluate it, and then evaluate f of a using the line chosen in step 1. So for instance, we have this function g of x equals 2x if x is less than 0, and it equals x if x is greater than or equal to 0. So we want to find these values. If I'm looking at g of negative 1, then which line am I going to use, the first or the second? The first, okay? We use the first part if we have x is less than 0. Negative 1 is less than 0, so I'm going to say 2 times negative 1, or negative 2. Okay? All right, what about g of 0? We're going to use the second, right? Because it's defined for x is greater than or equal to 0. So we get just 0. G of 0 is 0. And then for the last one, second one as well. Okay, g of 1 is going to be equal to 1 because it's defined from the second part. Okay, very good. So once we figure that out, then we could come up with a table of values or whatever we need so that we can graph our different functions. So here we want to graph g of x equals the absolute value of x for x is less than 1, and then x squared if x is greater than or equal to 1. Okay, so starting over here, for every x less than 1, we're going to evaluate the absolute value. If I put in 1, I get what? 1, except I'm going to use an open circle there since 1 is not included. Okay, if I put in 0, we get what? 0. We put in negative 1, we get 1. Negative 2, we get 2, and so forth, so on. Okay, these are solid. But this one is an open circle. Okay, this one right here. Okay, then I want to do x squared if x is greater than or equal to 1. So when I put in 1 to x squared, we get what? 1. So now I can make this a solid circle. Okay, if I put in 2, we're going to get what? 4. If I put in 3, I would get 9. Okay, so it looks something like that. And that's our piecewise function. Okay. Questions about that? Yes, that's right. Oh, well, for the range, you're right. The range would be from 0 to infinity. Okay, but the domain is all real numbers. Okay. All right, what about g of x? We've got x cubed. So if x is less than 0, we're going to use x cubed. So we'll start right here at 0, put an open circle there. At negative 1, if we cube that, we get what? Negative 1. Okay, at negative 2, if we cube that, we get negative 8. Okay. All right, so we're looking at something like that so far. And then for x is greater than or equal to 0, we're going to do the square root of x. So when I put in 0, I get 0. So we can make that solid now. Okay, and if I put in 1, I get 1. If I put in 4, I get 2. So that looks something like that. questions about that? Yes, it would. For the domain and the range, it would be all real numbers. Okay. All right, questions? Okay, very good. All right, so we're going to start talking about transformations of graphs. And it says if a new function is transformed by performing certain operations on a given function, f, then the graph of the new function is called a transformation of the graph of f. And we can get some idea about what these transformations look like based on the way that the equation is written. So our first transformation is going to be a vertical shift where d is greater than 0. If we have our basic function and then we add d to it outside of the function, just adding a constant at the end, then that's going to shift the graph up d units. Okay? Shifts it up d units. So here we have our basic graph of the absolute value of x. Okay, this is something that hopefully you would have a mental image of in your head. And if I wanted to graph the absolute value of x plus 3, I don't have to come up with a table of values. I'm just going to take some of these basic points and walk them up 3 units. So here I was at 0, 0. I'm going to take that up 3 units. Okay, this is a point at 2, 2. I'm going to take it up 3 units. Okay, over here, well, we have negative 2, 2. Take that up 3 units. Okay, and there's our graph. So by adding that 3 to the outside of the function, the absolute value is not applied to the 3. We do absolute value of x, then added 3 outside of that. That causes our graph to shift up 3 units. Okay? Versus if we say f of x minus d, then that's going to cause the graph to shift down d units. Or in this case, it would shift down 2 units. So here's my basic graph of absolute value of x. Take it down 2 units. And so without having to plot points, not really, a table of values or anything like that, we've got our graph. Okay. Questions about that? All right. The next transformation I think that we're going to look at is going to shift our graph left or right. Okay, everybody's got this? Okay, good. All right, so we've got a horizontal shift. And again, this is for c greater than 0. This time, instead of adding or subtracting outside of the function, it's happening right here inside of the function. Okay? And so when we do f of x minus c, you might think that that was going to shift left, but it's actually just the opposite. It shifts c units to the right. Okay, so if we've got f of x minus c, that's going to shift us c units to the right. Okay, versus down here, when we get to f of x plus c, again, the c is included inside of the function. It's going to shift us c units to the left. Okay, so here we have another graph, x minus 3 squared. Do you see how the 3 is inside of the square? Okay, not outside of it. All right. And so I'm going to shift which way? 3 units to the right. Very good. Okay, so again, we've got an image, the basic image of x squared in our minds. So we take those key points and shift them 3 units. 1, 2, 3. Okay, 1, 1 is a key point, so 1, 2, 3. Okay, let's see what else. 2, 4 is a key point, so 1, 2, 3. Okay. Here's another point. We're going to shift them 1, 2, 3. Okay. So that's the graph of y equals x minus 3 squared. Okay, questions about that? Okay. Then if we want we got y equals f of x plus c, and we're going to shift c units to the left. So here we have y equals x plus 3 squared, and I'm going to shift 3 units to the left, so walk it this way. 1, 2, 3. 1, 2, 3. 1, 2, 3. Okay. 1, 2, 3. 1, 2, 3. Okay. Questions about that? All right, good. Okay, so I want you to take a second and look at these next examples, and let me explain what's going on here. Here we have a basic function, 1 over x. Okay, this is one of our basic functions that hopefully you'll become familiar with. And then what I want you to do is to tell me what type of transformation we should expect when we do this to 1 over x. Everybody understand? For instance, with this first one, I can see that the 2 is on the inside of the function, right? So I would expect that it's going to shift 2 units to the what? To the left. Okay? Shifts 2 units left. And then this next one, the 3 is still on the inside, so it's going to shift which way? Okay, shifts 3 units right. All right, very good. So okay, there should be some other examples. What's happening with x take a look at those on your own for a second, here, and then we'll talk about them. Okay, shift up 2 and right 5. Very good. Okay, and then in h of x, what's happening? Okay, down 5 and right 8. Very good. Okay, questions about that? All right, so you'll see some problems similar to that on the test where I'm just asking you to describe the transformation. Okay, but also we'll see some like this where you actually need to graph the transformation. Okay, so what we're going to do is look at the equation. Our basic graph is what? X squared. So we're going to start by, if you need to, draw it out. X squared. Where's my ink? I have no ink. I want to draw this out in a different color. Hide. Yes. Okay. right, so our basic graph of x squared, we need to be able to come up with that quickly. It has points at 0, 0, 1, 1, 2, 4. Okay, also minus 1, 1, and minus 2, 4. Okay, that's our basic graph. If you want to, you can connect those points. Okay. All right, but now looking at this, what are we going to do to get the transformed graph? Okay, down 5, left 3. Very good. Okay, so I'm going to go down 5 and left 3. 1, 2, 3. Okay, that was this point. Take this next point, down 5 and left 3. I don't think that was right. Down 5, 1, 2, 3, 4, 5, left 3. 1, 2, 3. Okay, down 5, 1, 2, 3, 4, left 3. Down 5, 1, 2, 3, 4, 5. I did not drink coffee today. Left 3. Okay, there we go. All right, and we can use the property of symmetry for our parabola. We can keep shifting them, or, we can see that these things are equally spaced out about the vertex, right? Yes? Okay. So I don't have to keep moving the points. If I've got one, here's my vertex. I go up 1 unit and I go 1 unit left, so I also should be able to go up 1 unit and 1 unit right to get another point. Okay, for this one, it was 2 units to the left, so from here we're going to go 2 units to the right. Okay, or you can just walk the points down. Okay, and so there's our graph. Questions about this? Okay, very good. All right, so our next transformation is going to be a reflection about the x-axis. Okay. And so that happens if we put a negative in front of our function. Okay, if we put a negative in front of the function, then we're going to reflect it, flip it over the x-axis. Okay, so here we have basic graph of the square root of x, and what we want to graph is negative square root of x. All right, so we just have the negative of our basic graph that says take each point, flip it over the x-axis. So 0, 0 is on the axis, it stays there. We've got 1, 1, we're going to flip it over. And so it becomes 1, negative 1. Okay, we've got, let's pick a nice one, 4, 2, flip it over, it becomes 4, negative 2. Okay. And so it looks like that. Okay, but this negative is outside of the function. Versus reflection in the y-axis, we put the negative on the x. Okay, so do you see the difference between the two? Yes? No? Are y'all sad? Just sad. Y'all are so sad to be here. Okay. All right, so we're going to reflect it. Where did I say about the y-axis? Because we have a negative right here. So each point is going to flip over. Okay, 0, 0 still stays because he's on the axis, but 1, 1 is going to flip to negative 1, 1. And then our 4, 2 is going to be negative 4, 2. And so it looks like this. Questions about that? Okay, very good. No, for any, we're doing it for an example, but in general it is. Okay. So let's see. We have it again here. When we have our basic graph is f of x equals x squared. We've got g of x equals negative x squared. So we would expect what in this case? Okay, we're going to reflect. Where are we going to reflect? About the x-axis. Okay, the negative is not included inside the square. We squared it, then we did the negative. Okay. All right, versus with h of x, the negative is inside the square, and so we get what? Okay, we get a reflection about the y-axis, although in this case, would it make a difference? If we take x squared, think about what it looks like, and reflect it about the x-axis, how does that change the image? It doesn't, right? X squared looks like this. And so if we reflect it about the y-axis, it's still going to look just like that. Does that make sense? Okay, if I were to take this thing and flip it over the y-axis, because it's already symmetric, then it's the same graph. Okay, very good. All right, we want to explain the transformations. We got a few things going on here. Okay, think about this next one for a minute on your own. Okay, what do you think is going to happen? Okay, very good. All right, looks like we're going to reflect, okay, about the x-axis. And we're going to move shift right 1 unit. Very good. Okay, because that negative is on the outside. Our basic function in this case is what? X cubed. Okay, so what does that look like? X cubed has a point at 0, 0, 1, 1, 2, 8. Okay, minus 1, minus 1, minus 2, minus 8. Okay, that's the basic graph. Okay, now we want to reflect that about the x-axis and shift it right 1 unit. If you need to, you can do it in multiple steps. If you want to shift right 1 unit first and then do the reflection, that's fine. I'm going to try to do it all in one step. So taking a couple of these key points, like let's start with 0, 0. Of course, if we reflect it, he's not going anywhere. But when I shift right 1 unit, that puts him right here. Okay. Then, if I take this point Okay, I can shift him right and then reflect. Okay, take this point that was at 2, 8. I'm going to shift him right. It's still at 8, so now I'm going to reflect. Okay, come over here and deal with these. We're going to shift him right and then reflect. Okay, shift right and then reflect. Okay, so it looks like that. Right here? It would actually be, since we shifted it, looks like it's 3, -8. And then this one went over to -1, +8. Because we moved everybody 1 unit to the right. Okay? Questions about that? Okay, stretching or compressing, each y-coordinate of f of x is multiplied by a. Okay, but what we need to pay attention to is the size of a. So if a is greater than 1, then the graph is going to be stretched. Okay, basically we're multiplying all of the y values by something greater than 1 that makes them larger. So we're stretching it away from the x-axis. If a is between 0 and 1, then it's going to compress it towards the x-axis. And then, of course, we could still put the negatives in there that could reflect it across the x-axis. Okay, so for example, we've got y equals 2x squared. We already have our basic graph of x squared here. So take those key points, like 0, 0 times 2 is still going to be 0, 0. 2 times 1 is what? 2. Okay, then we had a point at 2, 4, but now that point's going to be at what? 2, 8. Okay, we got a point at -1, 1, but it's going to be at -1, 2, and also -2, 8. Okay, and so we're pulling this graph up, stretching it upward. Okay, questions about that? Okay. All right, in this other one, we're multiplying x squared by 1/2. So that's going to push each point down. Okay, so we get 0, 0 still. But here, at 1, we're going to come to what? 1/2. And at 2, we're going to come to 2. Right? It was 2, 4, but we multiplied 4 by 1/2, we get 2. Okay. All right, same thing over here. -1, 1/2, -2, 2. Okay. What about 3, 9? That would now become what? 3, 4.5. Very good. Okay, and -3, 4.5. All right, so our graph looks more like this. Okay, it's a little wider, we're kind of pressing it down towards the x-axis. And that's because the a value, the thing out front, the coefficient, is between 0 and 1. Explain the transformations to the basic graph and graph the function. Okay, so we've got g of x equals 4, the absolute value of x. How would we describe this transformation? Well, what is the 4 doing? Okay, we're multiplying it by the function, which causes it to stretch away from the x-axis, all right, by a factor of 4. So we're stretching it away from the x-axis. Okay, and we could say by a factor of 4. Okay, so absolute value function looks like this, basically. Okay, so I'm going to stretch by 4. I'll still have a point at 0, 0. I'm going to have a point at 1, what? 4. Okay, and at 2, 8. Okay. All right, at negative 1, 4, and at negative 2, 8. Very good. Questions about that? That's right. Well, nope. Let's go back. If we're multiplying by a number that's larger than 1, we're stretching. Or less than negative 1, we're stretching. Stretching and reflecting across. When it's between 0 and 1, we're compressing. Okay. All right, very good. Okay, what about this next one? What can we expect here? Okay, what's happening? Okay, we're going to stretch away from the x-axis. Okay, by a factor of 2. What else is happening? 2. Okay, we're going to shift right 1. Is that it? Not down 1. Not up 1. Not up or down. Not left. We already talked about right. We're reflecting. We've got a negative on that 2. So it's going to have to reflect across the x-axis. Okay, all 3 of these things. Okay, so let's get our basic graph first. Graph of square root of x has points at what? 0, 0, 1, 1, 4, 2. Okay, this is our basic graph. Okay, but then if I do all of these things, I'm going to stretch away. Let's do the reflection part first. I think that's going to be easiest for us. We're going to reflect and shift, and then we'll stretch. Okay, so I've got 0, 0. He's going to stay right there, except he's going to have to do what? Move right. Okay. All right, then this point, if we reflect it, comes down here, move it right, comes here. Or do I want to do this way? And then multiply it by 2, so it's going to end up right here. Okay, it was at 1 or -1, now it's at -2. Okay, this point we're going to shift right 1 unit. We're going to reflect. That puts them here, and now multiply by 2. That brings us down to -4. Okay. Okay, looks like that. So, looks a little bit like the reflection, but it's larger, okay, because we've stretched it away from the x-axis. Okay. Questions about that? Okay, very good. All right, now in this example, they want us to go in the opposite direction. They want us to write an equation for a function whose graph fits the given description. The graph of f of x equals the square root of x, is shifted 2 units down, reflected in the x-axis, and compressed vertically by a factor of 1/2. Okay? Think about that, and also the next one on your own for a second, and then we'll talk about what the answer should be. All right, very good. All right, questions about that? All right, what about B? Okay. All right, excellent. All right, any questions about these? Okay, we didn't talk about shifting or rather stretching horizontally.